As scientists, we are trained to follow evidence wherever it leads. We rely on measurements, observations, and data. No matter how surprising a result may seem, if the evidence is real, it deserves investigation. That is why a recent anomaly associated with Voyager 1 has captured the imagination of researchers and space enthusiasts around the world. Voyager 1 is humanity's most distant spacecraft. Launched in 1977, it has spent nearly half a century traveling farther and farther from Earth. It crossed the boundary of the heliosphere years ago and now moves through the vast darkness of interstellar space, a region unlike anything within our solar system. Most people assume that Voyager's greatest discoveries are already behind it. Its mission has long exceeded expectations, and many of its instruments were never intended to operate this far from home. Yet even now, the spacecraft continues to send information back across billions of kilometers. Recently, analysts examining a series of transmissions noticed something unusual. At first, it appeared to be a minor irregularity buried within the incoming data stream. Such anomalies are not uncommon. Spacecraft experience interference, electronic glitches, and occasional communication errors. Most strange signals eventually receive an ordinary explanation. This one did not. The pattern persisted. Researchers found recurring structures embedded within the data. Certain sequences appeared repeatedly. Mathematical relationships emerged where randomness was expected. Layer upon layer of organization seemed hidden within what initially looked like background noise. Naturally, scientists approached the discovery with caution. Extraordinary claims require extraordinary evidence. The possibility of instrument malfunction had to be considered first. Teams ran diagnostics. Communication systems were examined. Software models simulated possible errors. Yet the pattern remained remarkably consistent. As larger datasets were analyzed, the mystery deepened. Advanced machine learning systems were employed to identify relationships that conventional analysis might miss. These systems detected repeating mathematical structures, self-similar arrangements, and nested patterns that appeared surprisingly ordered. The results sparked intense debate. Was the signal simply an unusual natural phenomenon? Could it represent an unknown astrophysical process? Or was something entirely different occurring? What made the anomaly especially intriguing was its complexity. The structures appeared to operate on multiple scales simultaneously. Small patterns existed within larger patterns, which themselves appeared connected to even broader frameworks. Some researchers compared the arrangement to fractals, geometric structures that repeat similar forms across different levels of magnification. Others described the data as resembling a sophisticated information architecture rather than a simple transmission. No definitive conclusions were reached, but one fact became clear: the signal demanded further study. Voyager's location only added to the fascination. The spacecraft currently travels through a region of space that was once assumed to be relatively empty. There are no nearby planets, no major stars, and no obvious sources that would naturally produce such unusual behavior. Yet subtle variations in electromagnetic measurements suggested that the environment surrounding the spacecraft might be more complex than previously believed. Some theoretical models proposed the existence of large-scale interstellar structures that remain difficult to detect directly. Others suggested interactions between magnetic fields, charged particles, and cosmic radiation could generate unexpected effects. The scientific community remains divided, but everyone agrees on one point: there is still much we do not understand about the space between the stars. As artificial intelligence systems continued examining the data, they generated visual representations of the mathematical relationships contained within the signal. These models produced extraordinary shapes. Some appeared almost architectural in nature. Others resembled abstract networks or multidimensional geometries. Rather than simple diagrams, they looked more like conceptual frameworks, representations of relationships rather than physical objects. Of course, such visualizations do not prove the existence of an external intelligence. Human beings naturally search for patterns, and advanced algorithms can sometimes amplify that tendency. Nevertheless, the results were compelling enough to inspire new lines of investigation. One particularly fascinating aspect involved comparisons with humanity's own attempts at interstellar communication. When Voyager launched, it carried the famous Golden Record, a collection of sounds, images, music, and greetings intended as a message to any civilization that might someday encounter the spacecraft. The record was designed as a time capsule, a snapshot of Earth and humanity during the 20th century. Some analysts noted intriguing mathematical parallels between portions of the anomalous data and certain universal concepts commonly used in communication theory. Again, this does not mean a reply was received. There is currently no scientific evidence supporting such a conclusion. However, the observation raised an interesting question. If an advanced civilization wished to communicate across vast cosmic distances, what form would that communication take? Would it resemble language as humans understand it? Or would mathematics itself become the common foundation? Many scientists believe that mathematics may represent the most universal language available. Prime numbers, geometric relationships, and physical constants are not unique to Earth. They arise naturally from the structure of reality itself. Any technologically advanced civilization would likely recognize them. For that reason, mathematical patterns remain one of the primary signatures researchers search for when investigating potential extraterrestrial signals. The Voyager anomaly reignited discussions surrounding this possibility. Not because evidence of alien intelligence had been discovered, but because the event highlighted how difficult it can be to distinguish between natural complexity and deliberate design. The universe is capable of producing astonishing patterns without any intelligent intervention. From spiral galaxies to snowflakes, from planetary rings to molecular structures, nature often creates arrangements that appear almost purposeful. At the same time, intelligence itself emerges from nature. That fact complicates the search. How can we confidently identify an artificial signal if we do not fully understand all the ways natural systems generate complexity? The question remains one of the greatest challenges in modern astronomy. Meanwhile, Voyager continues its journey. Traveling at incredible speed, the spacecraft moves deeper into interstellar space with each passing day. Its aging instruments still provide valuable scientific information about a region humanity has barely explored. Every transmission represents a message from the frontier of our technological reach. Every packet of data expands our understanding of the environment beyond the solar system. Whether the recent anomaly ultimately proves to be a new physical phenomenon, an unexpected interaction within the spacecraft, or something entirely unforeseen, it serves as a powerful reminder of how much remains unknown. The farther we explore, the more questions arise. That has always been the story of science. Each discovery opens new mysteries. Each answer reveals deeper layers of complexity. Voyager 1 was launched as an ambassador of human curiosity. Decades later, it continues to fulfill that role. Its mission reminds us that exploration is not merely about finding solutions. It is about confronting the unknown and accepting that reality may be far stranger than our current understanding allows. For now, researchers continue to study the data, test hypotheses, and search for explanations. The anomaly remains unresolved. But perhaps that is what makes it so fascinating. Somewhere in the immense darkness between the stars, humanity's most distant spacecraft continues to whisper back to Earth. And hidden within those whispers may be new insights into the universe, new physics waiting to be discovered, or simply another reminder that the cosmos still holds countless secrets beyond our imagination? Until those secrets are revealed, Voyager 1 remains what it has always been, a symbol of exploration, curiosity, and the enduring human desire to understand what lies beyond the horizon.